All right, hello, welcome back. We are doing 3 merit questions again, and your revision in the lead up to the calculus external, which is coming up very soon. All right, so let me just sort out my window so I can keep a track on the chat if anything comes in. Okay, so if you got any questions while we're going through, just pop it up in the chat or just say hi and thank you for being here. Okay, so let's carry on with this complex stuff. All right, we've got a complex number 3 minus 2i, and we've got a v is 3 minus 2i, w is minus 4 plus 6i. We've got real numbers p and q such that this is true, and we need to work out what p and q have to be for this to be true. So let's first of all write down what that's telling us. That's saying that if we do p times 3 minus 7i plus q times minus 4 plus 6i, that will be equal to 6.5 minus 11i. Okay, so we can now look at those are being equivalent, which means that the real parts will be equal and the imaginary parts will be equal. So if we take the real parts, then we've got 3p minus 4q, and on the right hand side we've got 6.5. If we take the imaginary parts, we've got minus 7i, we've got minus 7p, we've got a 6q, and on the right hand side we've got minus 11. With that we can go do some simultaneous equations, because we've got 2 equations and 2 unknowns. So I'm going for the simultaneous equation solver here with 2 unknowns. We have 3, negative 4, and 6.5. And then we've got negative 7, 6, and negative 11. And then we hit solve, which gives us, although this one here on the screen refers to it as x and y's, here we are looking at that as being p and q. So we have p is 0.5 and q is equal to negative 1.25. That's such a lovely, easy merit question. I'll just check where the achieved point would have been sitting within that question. And it was for doing this part here, setting those things equal to each other. Actually, they wanted the expansion for achieved, which I didn't bother to do. I just picked it straight out. So let's just write that in there. That would be 3p minus 7pi minus 4q plus 6qi is equal to 6.5 minus 11i. So that line just there, that was achieved. Okay. All right, let's carry on with we'll move on to differentiation. So I did that one in probably about 3 minutes flat. And very quick for a merit question, feeling confident. Okay, let's go on with differentiation. So we've got a function here. We have some terms within that function. And we're going to find when is that function increasing. Now, increasing means that the graph itself will be going upwards as we move along the x-axis. So if the x-axis is like this, we're going upwards on our curve. So that means we've got a positive gradient. So we're looking for anywhere that the gradient is greater than 0. So first we need to find the gradient function. So we're going to differentiate each of these terms. So if we differentiate 8x, we get 8. Minus 3 is just a constant, so that differentiates away into 0. This one here, I'm just going to rewrite that as 2x plus 1 to the minus 1 first, because then that makes it easier to differentiate, or at least it does in my head. That's what I like to do. So we are using the chain rule on that one. So the minus 1 comes down and multiplies by the 2, so we get negative 2. the x plus 1 stays the same, and we reduce the power by 1. Now we want to know when that's increasing. That'll be when the gradient is greater than 0. I'm going to write that out as a fraction again, just to make it easier with the rearranging stuff. I'm going to be very careful about keeping my things on the right side of the inequality here. As we move things around, it's easy to accidentally switch that around so the inequality is then the wrong way around. So I'm being very specific about keeping things on left and right as we move around. Now bringing that x plus 1 squared up, it'll be greater than 2 over 8, and that cancels to a quarter. Now thinking about that as a curve before we carry on, what does that look like? We're looking for x plus 1 squared, which is a parabola that shifted left by -1. So that's x plus 1 squared. And we're looking for when it goes above 0. When it's greater, sorry, not 0, quarter. When it's greater than, oh, hang on, let me just do that again. When it's greater than a quarter. So just a little sketch on the side here can help you figure out what you're doing throughout the question. Right, now solving this thing, let's set it equal to a quarter first so that we can find, why did I put 14? Quarter. There we go. So we can find these points of intersection here, and then we'll figure out which side of it we need to be. Right, setting that equal to a quarter, now we can square root both sides. So that's plus or minus a half. So x will be -1 plus or minus a half. So x, if we do -1 plus a half, we're going to get negative 0.5. And if we do -1 minus a half, we'll get -1.5. So back to our picture, this one here, that's at negative 1.5, and this one is at negative 0.5. What that means is now if we're looking for where we go above the quarter line, we're looking for everything to the right of -0.5 and everything to the left of negative 0.5. So that helps us to write down our final solution. X has to be less than -1.5 and x has to be more than minus negative 0.5. All right, now that one again took us about 4 minutes. That's pretty good going for a merit question. Nothing too tricky in there. I'm just going to pull up the mark scheme and check where the achieved point was sitting within it. Okay, the very first step was achieved. This here, that was where the achieved is sitting within that question. Okay, just close that. Which leaves us with integration. We have this function here, we've got our x's and y's all mixed up together, so the first thing we need to do is separate those variables. So I'll bring the 4y up to the left-hand side and the dx up to the right-hand side, and then we will integrate both of those. Now integrating y, we're going to raise the power by 1, so that's y squared, and then divide by the new power. 4 divided by 2 is 2. If we integrate e, the e function itself stays the same, but we need to divide by the derivative that's inside of it. So this time we're dividing by 2, so we've got a half, and then of course we've got a plus c. Now use the information that we've got in the question, that's this bit here. X is 0, y is 4. So if we go 2, 4 squared is equal to a half e to the 2 times 0 plus c. Okay, so 4 squared is 16, and then we times it by 2, we've got 32. In fact, I'll write this down as I go. E to the 0 because 2 times 0 is 0. It'll be e to the 0. Anything to the power of 0 is 1. So that'll be a half plus c. So c is equal to 31.5. Now getting to that point there is often where a checkpoint might be for an achieved bit. So underline those bits as you go. It makes it easier for your marker to find it. Okay, now moving on to the final part, find the value of y when x is 2. Let's get this one here. All right, so 2y squared is equal to a half e to the 2 times 2, because we've got x equals 2. We've got c as being 31.5. So then let's just work that through. Let's go e to the 4 is going to get divided by 2. Then we add on 31.5. Then we'll divide it by 2. Then we'll square root it. And y equals 5.42. Okay, and hello to whoever it is that's sat through and watched all of it. Thanks for joining. The achieved point on that question, I'll just go back and check where that is. It was doing the correct integral. So achieved for this bit just here. There's your achieved point. Okay. And oh goodness, that really was a quick one today. So that was about another 4 minutes on that one. And 3 merit questions done within about 12 minutes. Nice and straightforward. Keep going with your practice. Join me again tomorrow. I will post the questions that I'm planning to do on my Instagram, and then you can have a go at them before joining with the live tomorrow, where I'll go through those solutions. So I'm just trying to think while I'm chatting of when we'll likely to be online. It's probably going to be in the evening. Just thinking what else I've got on tomorrow. Probably around 5:30. 5:30, maybe 6 p.m. We'll just see how the day goes tomorrow. But I will post that as soon as I have made a decision and can put that into my calendar. All right, I'll see you next time.